This is homework 3.4. And before I go over question number 1, I just want to review the properties of log with you. If you remember, we said if you have a log that has a base a and there is the argument a to some exponent r, the answer is just going to be that r. And so if I have an a and a, these numbers are the same, the answer is just going to be 1 because there is a 1 exponent here. So an example for this one would be log 2, 2. The answer is 1 because this is 2, then this is 2. The answer is just going to be the exponent of the argument, which is 1. Another property says if you have a log base a of 1, the answer is 0. So every time the argument is 1, this answer is 0 because a to the power 0 is 1. If I have a log base 2 and 1, the answer is 0. Why? Because 2 to the power 0 is 1. Another property was, which I haven't done with you before, if you have an a, this a has an exponent with logs involved, but this log has also base a, so you have an a here, and your exponent log has a base a of something here. The answer is going to be that. So for instance, if I have 5, and then 5 has the exponent of log base 5 of 7, the answer will be 7. So this 7 is going to be here. Remember the definition. If we have a log base a of m is equal to p, then we can write this as a to the power p is equal to that argument m, right? We can go back and forth between the two. The other properties were, one was log base a of m times n. These are the product. I'm multiplying two things. I can get log base a of this guy m plus log base a of n. So I have one log. I can write it as 2 logs. If I have a division, 1 log with a division for its argument, then I can write it as 2 logs, log for the numerator m minus log for the denominator n. So this division becomes a subtraction. Another property says if you have a log base a of m to some exponent r, this r could become the coefficient. So this r becomes the coefficient. So just having, some of it is review, and this is what we did in section 3.4, these new properties. So we want to apply them to question number 1, which we have log base 5, 25p. We have a product here, multiplication. I can write this as 2 logs. Log for 25, the base is 5, plus log for p. So this base is 5, is going to stay 5. But then you have 25 plus the other factor, which is p. And then you have to look to see if you can simplify it. For instance, this can be simplified. If this was log base 5, instead of 25, I had a 26, I would have left it as is. But I have a 25, so I can simplify it, and I need to. So what is the answer to this piece? We say, can I write 25 as 5s only? The answer is yes. So you can write this as log base 5. You can write 25 as 5 to the power 2. 5 and 5 are the same. The answer is 2. So instead of that, you write it as 2. And this cannot be simplified. So that is the answer to question number 1, which was that. Log 25p becomes 2 plus log 5p. Question number 2. We have log base 3 x plus y times z. So we said there is a property for product. We don't have a property for addition here. We don't have any property for this piece, but we have a property for parentheses times z. I can write this as log base 3 of this factor, x plus y, plus, this multiplication becomes plus log base 3 of z, because I have two factors. My two factors are this one and this one. So then I have a log for x plus 5 and I have a log for z. We don't have any property for this addition here. And that's your final answer. Question number 3. We have log base 3a divided by b. We have a property for division. We write log base 3 of the numerator a minus log base 3 of the denominator b. This is the denominator, this is the numerator. So I have one log, it becomes two logs. Question number 4 says log p cubed plus m divided by 1,000. So this division becomes subtraction. P cubed plus m. Make sure you put them inside the parentheses because you have two terms. There is no property for this right now. Minus log of 1,000. But remember, log by itself this is a common log. That means the base is 10. We can't simplify this one, but we can simplify this term. Why? Because we have 1,000 and the base is 10. We can write 1,000 as 10 to the power 3 because you have 3 zeros, then you write it as 10 to the power 3. So I can write this as log base 10 and 1,000 is 10 cubed. 10 and 10 are the same, the answer is 3. So this becomes 3. There is a subtraction and we can simplify this piece. And I can't put, you're not supposed to put a base. When you're working the problem on a paper, you can put the base 10 or base e. But when you put your answer in ALEKS, you're not supposed to put a base 10. So that is your final answer for this problem. Question number 5. We have a log 9x minus 9 to the power 4. So in this problem says use the power property. That means we don't want to have any power. We want to get rid of that power. There's a property that says that power becomes a coefficient. So remember, this power 4 only belongs to the argument. And if it is for the argument, you can make it a coefficient. What do I mean by that? Suppose they give you this problem, log of 5x to the power 4. You can't get rid of this 4 because this 4 belongs to the whole thing. But if you have a log 5x to the power 4, only 5x is being raised to the power 4, not log, then you can make that a coefficient. Okay? So I just want to make sure you understand the difference. Question number 6. We have ln ln 3 to the power kt. So we want to apply the power property. This kt becomes the coefficient. And that's it, that's the answer. So you have two exponents, k times t become the coefficient. Number 7. Write the logarithm as a sum or difference of logarithms and simplify. So we have a log, again base 5, 1/5, x to the power 2, and y. So we want to get rid of the exponent 2. We want to get rid of these multiplications. So let's do that. So we are going to write this as log base because the base is 5. And you have 1 factor, 2 factors, 3 factors. So you get log base 1/5 plus log base 5 of x to the power 2 plus log base 5 of y. We need to get rid of this 2. We make it a coefficient. And here you can write 1/5. Remember, we can write 1/5 as 5 to the power -1. Because 5 has a 1 exponent, move it to the top, becomes 5 to the -1. So we have a log base 5 of 1/5. We can write it as log base 5. 1/5 is 5 to the power -1. 5 and 5 are the same. The answer is -1. So this piece becomes -1. This 2 becomes a coefficient because that's the exponent for the argument. And that is your answer. Question number 8. We have log base 7, x to the power 6, y to the power 3, z. We want to get rid of the exponents. We want to get rid of the division. We want to get rid of that exponent, and we want to get rid of that multiplication. So we have a division to get rid of, we have a multiplication to get rid of, and we have exponents to get rid of. So let's get rid of the division first. That's the first thing we do. We get rid of the division. So you have the numerator first, you put a minus sign, then you write another log for the denominator. Before I get rid of the exponents, we are going to get rid of this multiplication. For this piece, we have a minus sign. For this piece, we get log base 7, y cubed, plus log for z. But since there's a negative here, and you have one term here, but it broke to 2 terms, make sure you put parentheses, because this negative belongs to both of them, or this negative has to be distributed. Negative times this positive, it becomes negative. Negative times that positive, it makes that negative. Lastly, let's get rid of these exponents, 3 and 6. So we move them and make them coefficients. And that's what Alex wants you to do. Question number 9, we have ln. I don't know why this jumps. P to the power 2, and we have a Q. So if you remember, I told you when you have exponent, the exponent, and when you have a radical, the radical can be written in exponential form. So note on the side, mn, this is what we have. We can write it as mn to the power 1 over 5, because if you put parentheses here, the exponent is 1, the root is 5, so you can write it mn to the power 1/5, okay? You could also write this as m to the power 1/5, n to the power 1/5. You can also do that too. So I think Alex shows it to you like that, but I think this makes it easier because when we are here, we have a multiplication. We can write this as m to the power 1/5, n to the power 1/5. Or if you have m times n to the power 1/5, you can write it as m to the 5th and 1 to the power 1/5. So anyways, I'm just going to go ahead and do that. Write this as m to the power 1/5, n to the power 1/5, p to the power 2, and then q. So now that we have done that, we are going to get rid of the division. So I write this as ln of the top, m 1/5, n 1/5, minus ln of the bottom. Then I can write this as ln m to the 5th for this piece. I have a multiplication here. I can write it as ln of m to the 5th plus ln for n to the 5th. I have a minus sign. So I can write this piece as ln p to the power 2 plus ln q. But see, you have one term here, now you have two terms here. So because of that subtraction, make sure you put the parentheses because this negative has to be distributed. And now at last you get rid of the exponent. So let's get rid of this, this. So you get a 5th ln of m, a 5th ln of n, 2 ln of p, minus ln of q. And that is your final answer. We have log base 4, 64, a to the 4th, 1 minus b, c, b plus 3 to the power 2. First, let's get rid of that radical. We have 1 minus b. You can't separate these. Here you had a multiplication. So when you have a multiplication, it's okay to write this as m to the power 1 over 5, n to the power 1 over 5. But here you have a subtraction, or if you have an addition, you can't do that. So you have to look at this as one whole thing. It has a 1 exponent. You can write it as 1 minus b to the power 1 over 2. If there's a subtraction or addition between the two terms, you cannot break this as 1 and then b. You have to look at this as one whole thing. The whole thing has a 1 exponent. So anyways, I'm going to get rid of that exponent here, that radical, and write it as 1 over 2. So I want to get rid of this, get rid of that, get rid of that, get rid of that. So first we start with the division. I write it as log base 4, 64, a to the 4, 1 minus b to the power half. This division becomes a subtraction. And then I have another log for the denominator, c times b plus 3 to the power 2. We are going to get rid of the multiplications and write this as log for 64 plus log for a to the power 4 plus log for 1 minus b minus, again, this breaks into two logs, log base 4 of c plus log base 4 of b plus 3 to the power 2. But again, don't forget to put the parentheses because here you have one term, now you have two terms. This negative will flip the signs for both. So not only that is going to turn, positive times negative is negative. This also becomes negative. Then what happens is also these exponents become a coefficient. This 4 goes here, this 1/2 goes here, and that one is a 2 that goes here. So the exponents are gone. Let me just write this a little bit more neatly. So this is minus log base 4 of c minus 2 log. This is what we had. I don't know if it was clear. So now, the last thing we want to do is simplify that. We have a log for 64, and you say, can I write 64 as 4's only? 64 divided by 4 is 16. 16 divided by 4 is 4. Sure, you can write 64 as 4 to the power 3. So I'm going to write that as 4 to the power 3. So I have a 4 here and a 4 here. The answer is 3. So instead of log base 464, I'm just going to change that to a 3. This is a 3. So that is the final answer. Question number 11. We have log. Question number 11. We have a log 12/9 plus log 12/16. So for this problem, we want to go backward. We have an addition. We want to get rid of the addition and write it as multiplication. Oh, remember the property says if you have log base a, m times n, you can write it as log base a, m plus log base a, n. So you have addition, you can write it as multiplication. So now we have an addition, we want to get rid of the addition and write this as a single log. So when we want to write it as a single log, we get rid of that addition, we write it as 9 times 16. But 9 times 16 is 144. And then the question is, can we simplify this any further? The question is it possible to write 144 as a 12 to some exponent? And the answer is yes. 144 is divisible by 12. 144 divided by 12 is 12. So we can write 144 as 12 to the power 2. 12 and 12 are the same. The answer is 2. So the answer to this problem is 2. We got rid of the addition. We wrote it as one single log, 9 times 16. I multiplied 9 and 16, I get 144. I can write 144 as 12 times 12, which is 12 to the power 2. Since 12 and 12 are the same, I just get 2. So the answer to this is 2. So the answer to the first one is 2. We have question 12. We have log base 6 of 2,496 minus log base 6 of 32 minus log base 6 of 13. So every time you have a subtraction, you can write this as a division. So we have this property that says log base a of m over n is log base a of numerator minus log base a of the denominator. So just let's look at two terms at a time. We are going to look at these two. So I have a subtraction. I write it as one single log of the numerator, 2496. The first one is the numerator. 32 is the denominator. And then I write the next one. And again, I have another subtraction. This is the numerator. That's the numerator. This becomes the denominator. So just put it in the denominator. So that is your numerator. This is your denominator. When you're doing the subtraction, if there's a subtraction, this guy goes into the denominator. If this was an addition, it would have gone to the numerator. That's just a shortcut. So now the question is, can I simplify this and see what I get? Is 2,496 divisible by 32? I'm going to use my calculator and see if I can divide them evenly first. So I have 2,496 divided by 32. When I divide these two, I get 78. So this is log base 6, 78 over 13. And then 78 divided by 13 is 6. So I get log base 6. This whole thing is equal to 6. 2,496 divided by 32 is equal to 78. And then I have a 78, so I could have written this as 78. I could have reduced it and then written this as log base 6, 78 divided by 13. And 78 divided by 13 is 6. When these two are the same, the answer is the exponent of the argument, and the exponent is 1. So the answer to this whole thing is 1. So the next question is question 13. We have 5 log base 2r minus 9 log base 2s minus 4 log 2t. So you could only use the properties we stated if these coefficients are 1. Then you can wrap them, you can join them, write them as a single log. So I can't write these two as one log when I have a coefficient here. First, let's get rid of these coefficients, turn them to an exponent. Use the property that if I have log base a r to the power m, this m becomes a coefficient like that. So we are going this way. I have a coefficient, I make it the exponent. So that 5 becomes the exponent of r. 9 becomes the exponent for s. And 4 becomes the exponent for t. Now that the exponents are gone, I can use the property and write this subtraction as one log. This is the numerator. This is the denominator. And then I have this one. And since there's another subtraction, this becomes the denominator. So I join these two as one log. T to the power 4 goes into the denominator. And that is your final answer. You just wrote everything as one log. Question 14. Again, we want to write the logarithmic expression as a single log with one coefficient. So I have 9 log c half log d minus half log k. So we are going to get rid of the coefficients first. So when you're writing these expressions as a single log, you need to get rid of the coefficients first, okay? So 9 becomes the coefficient of c. Half becomes the coefficient of d. This half becomes the coefficient of k. I mean the exponents. So now I don't have any more coefficients, they're all exponents. Now I can use this property and write this as one log, join these two as one log, numerator, denominator. Again, this subtraction send this argument into the denominator. And remember, if you have d to the power 1/2, you can write it as a square root of d. If you have k to the power 1/2, you write a radical because of that. You put k here. The exponent of k is 1. The root is 2. But when the exponent is 1 and the root is 2, we know that is true by default. You don't need to write it. Another property is that they're being multiplied by each other. So I have d to the half, k to the half. This is a square root of d. This is a square root of k. Since it's a multiplication between them, we can write it as a square root of dk. So they want you to go through all these steps and write this as a square root of dk. So the final answer is log of c9, the square root of dk. So that's how you get this square root. So question number 15, we have the following: a fifth, 35 ln c plus 8 plus ln of c minus ln of c to the power 5. You could make this 35 the exponent for that, but this 1/5 needs to be distributed, gets multiplied by every single term first. So before I make 35 the exponent of c plus 8, I'm going to distribute that 1/5 with every term inside the bracket. 1/5 times 35, 1/5 times 35, top times top, bottom times bottom, 35 over 5 is 7. So I get 7 ln of c plus 8. Next, I want this 7 to become the exponent of c plus 8. Now I use the properties and write this expression as a single log. Then you have addition. You write this as 1 ln, but then you write this argument times that. You have c plus 8 to the power 7 times c. I like to put c in the front, so it doesn't matter. Then I have minus ln of c to the power 5. Then because of that subtraction, this moves to the denominator. I write this as 1 log. I have a c plus 8 to the power 7 over c to the power 5. Lastly, this problem needs to be simplified further. Do you see you have a c here that is being multiplied by this parentheses? This c and one of these c's simplify and you get c to the power 4. So the final answer is ln c plus 7 to the power, c plus 8 to the power 7 divided by c to the power 4. And you can't simplify anything any further. So that is your answer. I just want to check one thing. Did I mess up somewhere? I forgot to multiply that ln. Oops, I made a big mistake. So let me just redo this whole thing. I messed up somewhere. Let me just rewrite it. I forgot to distribute that 1/5 after all. So we have, this was our problem. We have 1/5, 35, ln c plus 8 plus ln of c minus ln of c5. The first thing we have to distribute that 1/5. 1/5 times 35, I showed you that is 7. So once that 1/5 is distributed, now get rid of the coefficients, make them the exponent. So this becomes ln c plus 8, put the 7 outside the parentheses, plus ln of c to the power 1/5 minus ln of c to the power 5 times 1/5. So you have 5 times 1/5. 5 and 5 cancel each other, you get ln of c. So 1/5 times 5, 1/5 times 5 is 5 over 5, which is 1. So that's why this whole thing becomes 1. Now that this is simplified, that's what I had forgotten on the, I made a mistake. I forgot to distribute that 1/5 completely. I multiplied 1/5 by 35. I wrote it as 7. Then I forgot to multiply it by these guys. So now we are going to get rid of this addition. We join these two as 1 ln c plus 8 to the power 7 times c to the power 1/5. Then we have minus ln of c. Then we get rid of that subtraction, and this becomes the denominator. So these two are going to become ln of the numerator divided by the c from the second ln. Do you see you have a c to the power 1 and you have c to the power 1/5? These two will be reduced. How do you reduce them? Let's look at this. You have c to the 5th over c to the power 1. 1 is bigger than 1/5. I'm going to subtract 1/5 from 1. This was a lesson we had at the beginning. If you have 2 to the power 5 divided by 2 to the power 3, 5 is bigger than 3. So do the subtraction on the top. You go 5 minus 3. The answer is 2 to the power 2. On the contrary, if you have 2 to the power 3 over 2 to the power 5, then go 5 minus 3, do the subtraction on the bottom, and you get 1 over 2 squared on the bottom. So whatever exponent is bigger, just do the subtraction where the exponent is bigger. If the exponent is bigger in the bottom, then do the subtraction at the bottom. If this exponent is bigger on the top, then do the subtraction on the top. 1 is bigger than 1/5, so you put a 1 on the top. You go 1 minus 1/5. You subtract 1/5 from 1. So what is 1 minus 1/5? You multiply 1 by 5 over 5, because the common denominator is going to be 5. So we multiply 1 by 5 and this 1 by 5. You get 5/5 minus 1/5, which is 4/5. So we end up with 1 over c to the power 4/5. So these two will be reduced, and we will get ln of c plus 8 to the power 7 divided by c to the power 4/5. So you have a c to the 5th and c to the 1. Subtract that exponent from that exponent, and you get 4/5. Lastly, Alex wants you to get rid of that and write it as a radical. When you have exponents that are fractions, that means you can write this as in radical form. So you put the radical, c goes under the radical, 4 is the exponent, 5 is the root, and that is your final answer.